We're working in section 4.4 and we want to look at an application from chemistry. The pH of a solution is defined by this formula here. It's equal to the negative common log of the hydronium ion concentration of the solution. You may know that pH values measure acidity or alkalinity of the solution, and that pure water has a pH of 7.0. So substances with pH values greater than 7 are alkaline, and substances with pH values less than 7 are acidic. In this first example, we want to find the pH of a lime with this given hydronium ion concentration. So we're just going to plug into the formula. We'll write the pH is equal to negative common log 1.6 times 10 to the negative 2. We could also rewrite that. Scientific notation is common in this application, but we can also convert that number to a decimal. And so in particular, if we're going to multiply by 10 to the negative 2, that just means move the decimal point 2 places to the left. And so we would wind up with 0.016. So we want negative log of 0.016. Oh, it's worth mentioning one more thing too. The common log of 0.016 is a negative number, right? If the argument is between 0 and 1, then the log of that number is negative. And so then there's a negative sign out in front to make your answer positive, to make the answer positive. So let's go over to the calculator and let's type this in. I've already done it once. Let me try this again here. So let's go to function and common log, and then I can type in 1.6 times 10 raised to the negative 2 and hit enter, and there's my answer. If you'd like to see it in the other form, you could also type in the log of 0.016 and get the same answer. And remember, the log is a negative number, but there's a negative sign in front of that, so our final answer is positive. It's going to be positive 1.8 if we round to one decimal place, 1.8. So let's come over and write that down, 1.8, and we can box that up and we're done. Okay, so in the first example, we were given the hydronium ion concentration and we found the pH. Now, in the second example, we're given the pH and we're asked to find the hydronium ion concentration. So on the left side here, I'll write on the left side of our formula, I'll write 7.4. That's the pH that's given in the problem, is equal to negative log of the hydronium ion concentration. So 7.4 is equal to negative log of this. And let's see here. If we're going to solve for the hydronium ion concentration, then there are two things we need to move out of the way. We need to move this negative sign first, and then we need to get rid of the log as well. So let's do this one at a time. Let's multiply both sides by the negative sign. Multiply both sides by a negative 1, and we'll have negative 7.4. We'll have negative 7.4 is equal to the common log of the hydronium ion concentration. And then remember the base is 10, and so if we want to undo the common log, then we're just going to put a base 10. We're going to create a base 10 exponential on each side. So let's see what that looks like. Let's write the base 10 underneath both sides of the equation. And I'll write in the base 10 on the log just for emphasis here. And so over here on the right side, the base 10 in the exponential and the base 10 in the log cancel each other out. And we're just left with the hydronium ion concentration that we're looking for. So all we need to do is evaluate 10 to the negative 7.4 on our calculator. Let's come over here and let's type in 10 raised to the negative 7.4. And there's our answer. Notice the scientific notation. Your calculator might not give scientific notation right away. If it doesn't, then you may have difficulty interpreting your answer because there will be so many leading zeros before the 398. And so you might have to go into, on your calculator, you might have to find a button mode, and then underneath mode, or within that that menu, you should be able to find an option for scientific notation. It may be abbreviated SCI. Okay, at any rate, we're going to round off to 1 decimal place in the scientific notation. So we're going to have, instead of 3.9, that 8 says we have to round the 9 up to 0, and then that brings the 3 up to 4. So we'll have 4.0 times 10 to the negative 8. 4.0 times 10 to the negative 8. So our final answer here is to say that the hydronium ion concentration is 4.0 times 10 to the negative 8. And we can box that up.